Hello. In this video, we want to look at some definitions. We're going to begin with first getting my pen working here. And there we go. So let's begin with this one. Angular velocity. Now, angular velocity says if a point is in motion on a circle through an angle of alpha radians in time t, then its angular velocity omega is given by omega equals alpha over t. Now, alpha is just the angle. Omega is an angular velocity. Okay, so omega is angular velocity. There we go. Omega is the angular velocity. And basically it means how quickly is something going around in a circle. And that's really all it is. Now, in terms of units, whatever the units of alpha are, whether they be in radians or degrees, over the time unit. So this is an angle over time. So angle per time. Now, if we're talking in radians and time is in seconds, it would be radians per second. If we're talking in degrees and time was in hours, it'd be degrees per hour, and so on and so forth. Next, let's look at linear velocity. Linear velocity will be related. So if a point is in motion on a circle of radius r through an angle of alpha radians in time t, then its linear velocity is given by v equals s over t. Okay. Where s is the arc length divided or determined by s equals alpha r. Good deal. I was worried about that for a second. Now, because linear velocity is what we're looking at, v is what we're using for linear velocity. And basically, velocity is effectively what we're looking for in terms of just regular velocity, miles per hour, something like that. But notice that because this is linear velocity, and we're talking about motion on a circle here, the distance that it travels will be the directed arc length. Well, an arc length, basically. So s equals alpha r will be what s is. So you can think of this in terms of alpha r over t. That works just as well. Now the units, s is just a distance unit, say feet or something like that. Time is in, say, maybe seconds. So the units here would be feet per second, or distance over time. Distance unit divided by time unit. Now for the last one. Linear velocity in terms of angular velocity. Now I've kind of already looked at this a little bit, but let's do it again. So have I looked at it? No, I haven't. Never mind. Ignore that last bit. If v is the linear velocity of a point on a circle of radius r, and omega is its angular velocity, then v equals r omega. Now, really, this isn't really that difficult, because velocity is just, well, how quickly something is going in the actual distance. Now think of a slingshot. If you take a slingshot, or a sling of some sort, and you twirl it around in the air, if it's a small size and you twirl it around, let's say 1 turn per second, then its linear velocity is going to be whatever that would be. Now, let's say that you then extend that. If you doubled that length, even if you're swinging at the same angular velocity, the same revolutions per second, then it has a doubled linear velocity because it has to go double that distance that the one that was half its distance did. So it has to, as the radius goes up, the linear velocity goes up. But notice that the angular velocity would stay the same. Alrighty. Well, I think that's it for this video. I'm going to go ahead and go on to the next one, and we will start working with some questions. I'll see you there.